The last module of Chapter 18 is now parameter estimation. Namely, we're going to really look at two different subjects in this module. The first one is parameter estimation, and the second one is the distribution of prices in the real world and to what extent they look like log-normal distributions. So the log normality assumption really has two important implications. One is that the returns, if we look at continuously compounded returns, that distribution of returns on any period are normal. And secondly, that the mean and the variance of those returns are proportional with the interval of time. So that if we looked at the mean and the variance of returns over 1 year, that would be half the mean and the variance of returns over 2 years. And again, we're not talking about annualized returns. These statements would not be true for annualized returns. What we're saying is just the total numerical return over a 2-year period will have double the mean, double the variance of the total numerical return over 1 year. So that's the implication. We have a model that says that between time t minus h and t, time interval of length h, where again we'll just assume that all of our time is counted in years or measured in years, so that alpha, delta, and sigma are all annualized parameters, we would have this formula for the stock price. We take the beginning of period stock price, and then we have an exponentiated return that follows a normal distribution. We have a mean and a variance, and z is now standard normal. So if I take the log of the ratio, I get this expression, and then we can easily see from this model that the expected log ratio, the expected return, is this parameter, and the variance of the log ratio is that parameter. Of course, those come directly from the parameters of the log normal distribution. So we can now look at some data. Imagine that we have price data for a stock series, some price data, and this happens to be in weeks, and we can just simply calculate the log of the ratios. And notice this is a typo here. That -1 should be in the subscript t, as you see in the header of the second numerical column. So what we're looking at is the log of the end of week price divided by the beginning of week price. So these are now going to be returns for 1 week periods. And we take these, and so here's a sampling. We have 7 prices. It's a sampling of 6 returns for weekly returns for this particular stock. Now, from this, and of course in practice you would use more data than 7 weeks, but the numerical calculation is the same, we can calculate the mean and the variance, or the mean and the standard deviation of this column of 6 numbers. And we find that the mean is, in natural units, 0.0067. Which you might think of as 67 basis points. So what we're saying is that the average continuous return for each week is 67 basis points. The standard deviation over this period is 3.8%, or 382 basis points. Okay, so a fairly volatile period of prices. We have an average return of 67%. 67 basis points, and we have a volatility of return of 3.8%. And these are in units of weeks. Neither one of these is annualized. So we now need to talk about, well, what would be the parameter in our model sigma? We have to annualize the original one. Well, recall that the variance is proportional to time, and therefore the standard deviation is proportional to square root time. So if we want to go from a weekly standard deviation to an annual, we have to multiply by the square root of 52. And we get, as we can see here a 27.55% vol. Pretty high volatility, 27.5% standard deviation. Now this is an annualized standard deviation. We also now need to annualize the expected return. And what do we have to do? Well, we have to annualize the weekly return of 67 basis points, and that the return, the alpha part of the return is just proportional to h and time. So we multiply by 52, but then you recall we have an adjustment for the half variance. So we need to add the half variance, and we get 38%. So what we observe from this very short time series is that if these prices are going to be assumed to be normally distributed, or if these returns are going to be assumed to be normally distributed, which means the stock prices are log normally distributed, we're going to have a model where we have an annualized expected return alpha of about 39% and an annualized volatility of around almost 28%. Of course, both of these have estimation error, and in this particular application with only 7 prices, the estimation error would be huge. But even if you had weekly data for a year or two, which you might find on yahoo.com or some other website, you will still always have estimation error.